Okay, in lesson 6.7, we are going to begin to solve exponential equations and logarithmic equations, and there may be some e's flowing around also. And so here we start out with e to the x equals 1. Now I'm going to solve this with what I call pure common sense, okay? Notice here, we're not trying to find e. We already know what e is, right? We know that e is a number like pi, only it's 2.7, blah, 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 on and on and on and on forever. And so what e to the x, we're solving for this. What number can we plug in for x that turns this all into 1? Well, hey, what's anything to the 0 power? Oh, it's 1. And so in this case, x equals 0. All right? X equals 0. Okay, well that was commonsensical, but this next one is not. So how do we solve them? What's the mathematical process? Well, the mathematical process to solving an exponential equation is taking the logarithm of both sides. And so I'm going to go, and what you're going to want to do is make the base and this base, make those numbers match, okay? And so I'm going to take the log base 5 of both sides. You see what I did? Log base 5 of 5 to the x equals log base 5 of 12. And something happens right here. Something incredible happens right here. This all cancels out and gives you an x. Yes! It's magical, okay? When these numbers are the same, that's always going to happen. So look for that. It's going to be a very helpful process. Now then, x equals this. Well, how can I solve that? Well, remember last section when we learned the change of base formula? Yep, it's just going to be log of 12 divided by log of 5. All right, that looks like an 8, but it's a 5. Do that on your calculator. You've got your answer. All right? I'll do it real quick. Log 12 divided by log 5. You should get 1.544 when you round off. Okay? So taking the logarithm of both sides is one way to solve these. Okay? So we're going to do the same thing here, but what log should we use? Well, hey, we need to use the logarithm with a base e. What's another way to say logarithm of base e? It's the natural log. Okay? And so what happens, remember, this is really log base e of e to the 2x. What happens here? Everything cancels out, and we're just left with a 2x. Okay? Natural logs cancel out e's, or log base e, and this e will cancel out and we'll give you this. We have a natural log button on our calculator, and so to get x, we're just going to divide both sides by 2, and whatever the natural log of 4 is divided by 2, that's your answer. Okay? Again, what did we do? We took the logarithm of both sides, and we made these bases match. Right? Now, we're going to eventually do that here, but we're going to use some normal equation solving stuff to get that e to the x, to get the variable part of it, all right, all by itself. So let's subtract 7, and that'll give us 3 times e to the x equals 2. Let's go ahead and divide by 3, and that'll give us e to the x equals 2/3. Now it's time to take the natural log. Why natural log? Because this is an e, and what does the natural log do to the e? It cancels it all out and leaves you with an x. And so whatever the natural log of 2/3 is, that's what you get. What is the natural log of 2/3? I'll tell you. It is negative 0.405. Okay? All right? Now, here's something interesting. We could go ahead and take the logarithm of both sides, but I want you to look at the bases that you see here. this has a base of 3, and this has a base of 3. Well, when the bases are the same, then you can just take the exponents and set them equal to each other. All right, so negative 3x plus 1 has to equal x minus 9. I'm going to choose to add 3x and add 9. And so what's that going to give us? 10 equals 4x. Divide by 4, and you get x equals 5 halves, or 2.5. Okay? So sometimes if those bases are already the same, you don't have to do anything to them. Now here the bases aren't the same. One base is a 9 and one base is a 3, but I know how to change 9 into a 3. Isn't 9 the same thing as 3 squared? All right? And so now the bases are the same. What happens right here? Well, that becomes 2 times 2x, and that's going to be 3 to the 4x equals 3 to the 2x plus 4. Since these are the same, I can just set the exponents equal to each other. Subtract 2x, get 2x equals 4, divide by 2, get x equals 2. All right? Okay, so that's how you solve equations, exponential equations. How do you solve when the exponent is the variable, when there's an x as an exponent, right? How do you do it? You take the logarithm of both sides. Are there other things you can look at? Yes. But if all else fails, just take the logarithm of both sides and you'll get there. Now, we're going to switch it around and we're going to run into equations that have logs in them. So how do we solve logarithmic equations? Well, there's a couple different ways we can go about it. The first way we can go about it is we could change it into exponential form. All right, remember the circle the wagons thing? All right, this is log of x, so it's a base 10, okay? So if I circle the wagons, we would say 10 to the third equals x. Well, I know what 10 to the third is. It's 1,000. And so the answer is 1,000. And so I got that. This was not a base. That was up here, all right? And so I did the circle the wagons things. That's one way to do this, all right? It's not always going to work for you, but it's one way to do it, all right? Another thing is to simply notice, hey, wait a second. Look, this problem has log base 7 on both sides, doesn't it? Well, if these are the same, then that means these two things have to be equal. So 2 minus x equals 5x. Let's add x to both sides. We'll get 2 equals 6x. Divide by 6, and you get x equals 1/3. Okay? So if you ever see this, you can just set these two things equal to each other. All right? All right? We could circle, here's another one. We could circle the wagons here. All right? And we could, this would give you 4 to the 6th power equals 3x. Well, so you could just say, okay, 4 to the 6th, that's a calculator problem. That's 4,096 equals 3x. And then we'll divide that by 3. I think you get an answer of like 1,365 and a third. Okay? All right? Sometimes we'll want to get rid of stuff. Let's get rid of the 2 here. And let's make this log base 7 of 1 minus 2x equals 6 now. Okay? So we could do the circle the wagons thing. All right, that'd be 7 to the 6th power equals 1 minus 2x. Now, let's just do it. All right, 7 to the 6th. Oh, that's a big number. It's 117,649. I ran out of room here, so 1 minus 2x. So I'm going to subtract 1 and then divide by negative 2. So minus 1 Dividing by -2, it's going to be, oh no, I squared it, sorry. So I need 1,017,648 divided by 2. It's going to be like 58,824. Okay? Here's another one. Notice, what do you see here? The log base 6 on both sides. Oh, but these are on the same side, aren't they? Let's use our properties. If this is a plus sign, then that means we can multiply these together, can't we? So this is really log base 6 of 2x squared minus 6x equals 2. And now you can circle the wagons. Oh, but we don't want to, that's going to be 6 squared equals 2x squared minus 6x. Okay, so that's 2x squared minus 6x equals 36. Let's bring that 36 over to this side, and we'd have to subtract it. Let's take out a 2. And let's see, are there any factors of 18 that subtract to give us 3? 6 and 3, right? Okay, so x and x, 6 and 3. This has got to be a minus, and that's got to be a plus. So we've got possible answers of x equals 6 or x equals -3. We probably should check them because it's possible one of them could be extra, or what we call extraneous, all right? One of them might be a faulty answer, and so you go back and you check it out. Let's take 6 and plug it in here. That would be 12 minus 6. That'll be 6. That's going to work out, I think. What if we put -3 in here? Oh, you can't use -3 because now you're going to be taking the log of a negative number, and we can't do that. It's not possible, all right? Hopefully that'll help you solve those logarithmic equations and exponential equations. Good luck.